Hello everyone. We are going to go over the notes for our first section in our integer unit. We're going to talk about a few different things and then we will enter into some new material about multiplying and dividing integers. So to start, we're going to look at the word integer, and as we've seen in class, this means a positive or negative number. We're working just with whole numbers, but remember that these could be part numbers as well. Decimal numbers and fractions can be both positive and negative. Now, factor we've talked about in class as well, and that is a number that is multiplied. Okay. And finally, a product is a answer to a multiplication question. Okay. So we will be using these terms in class all the time. So you should familiarize yourself with these definitions. When we're multiplying numbers, there are two ways to represent the multiplication. So the first thing that we would talk about, and these are strategies you've done in the past, the first thing that we would talk about is a repeated addition. So we would do, what this means is 3 times 2. Okay, this 3 times 2, these factors mean 3 groups of 2, or we can turn around, it can mean 2 groups of 3. So the repeated addition would be like 3 plus 3 plus 3 equals 9. Oh, I did that incorrectly. It would actually be 3 plus 3 equals 6, or 2 plus 2 plus 2 equals 6. Okay, equal groups, we've all seen this as well, where we're drawing equal groups and counting those. So we have 1, 2, 3, 1, 2, 3. That means we have 6. We could do the same with the 2 plus 2 plus 2 plus 2. Okay, so 2 groups, and 2 groups. And we've seen this in class. We are just making sure that we go over this again. So we've done these examples in class, so we're just going to continue to move on. And we've talked about this, multiplication with negative integers, okay? So one of the things we have to think about, if one of the factors is a negative number, you can still use the strategies of repeated addition. Or equal groups, okay? But now we must use negative numbers. Okay, so we can do the same thing. This time it means 5 groups of negative 4. So what we would do is we would go negative 4, and we're going to maintain our brackets all the way throughout. Make sure I do enough of them, and not too many this time. And that gives me negative 20 if I were to add that all together. We could draw this too, so I'm just going to draw one group, but we would use our algebra tiles in this case, and I would draw 5 groups of negative 4. So you can continue to draw those, right, and then you would count them all up, and again you would get that same negative 20. So these strategies are things that, yes, we can use if we were really struggling with the multiplication piece, but we are should be fairly familiar with our multiplication tables. So we really need to try and see if we can find any patterns and look to see if there's a rule that we can follow. So the first thing that we need to talk about a little bit right now is the commutative property. And I struggle to pronounce that word properly, but I did so this time. So the commutative property. So in this, what this means is that the order of the factors in a multiplication, and I'm not going to have enough space, so I'm going to write above question, does not make a difference. So the one I always go back to is 2 times 3 equals 6, and that is the same as 3 times 2 equals 6. Addition is also uses the commutative property. Now, the commutative property does not work for subtraction and division. If we switch the order of the numbers in subtraction and division, we're going to get a completely different answer. So if the first factor is negative and the second factor is positive, we can use the same strategies as we did before. Like I said, normally we would say, okay, negative 5 groups of positive 6, but that's really awkward to try and draw or to use a repeated addition, because you're going to have to try and take away or 5 groups of positive 6, and you're going to end up drawing a whole bunch of 0 pairs. So if we think of that as still 6 groups of negative 5, we would go negative 5 plus negative 5 plus negative 5 plus negative 5. And we're going to do that 2 more times. And for those of us who have been counting all along, we get a negative 30. Okay. Now you might have started to notice a pattern a little bit. We could do the next one as well. 5 groups of negative 2. The answer is going to end up being negative 10. Okay. And then for the last one, 9 groups of negative 6. The answer is going to end up being negative 54. So what's the pattern that we start seeing? Well, what we see is that if both numbers are positive, okay, when both factors are positive numbers, then the product is a positive number. Remember, product is the answer, okay? So if we have a positive, and I'm just going to put positive there, okay, times a positive, our answer is going to be a positive. So if both factors are positive, okay, that means that our answer is going to be positive as well. Okay, and then if we think about that, what we just saw in here is that up here, okay, is that we have one negative and one positive factor. So when one factor is a negative number and the other factor is a positive number, our answer is going to be negative. Okay, so if we have a negative times a positive, we get a negative answer. And the same is true as if we have a positive, just going to write underneath, times a negative. Okay, because of the commutative property where the order of the factors does not matter, as long as the symbols are opposite, so if we have a positive and a negative, then we're going to get a negative answer. And we see this pattern all the way through. And the pattern is actually going to carry over into division. Because multiplication and division are related, it's going to carry over. So now, what would we do if both factors are negative? Well, we need to think a little bit differently. I'm never really going to ask you to model this, but I'm going to show you the model, so hopefully it'll help you understand. So what I say here in the notes is that we must think about taking away multiple groups of negative numbers. So the example I'm going to use is negative 3 times negative 4. So what we need to do is take away 3 groups of negative 4. Oh, you see there that I have some French still in my notes, and you may have noticed that on your written copy too, so I'm just going to cross those out. We don't need to pay attention to that, but if you are paying attention, those two phrases mean the same thing. So what that means is that we have to start with groups of 0 pairs, okay? And as we discussed, a 0 pair is when you have a positive and a negative, and you put them together, they equal 0, okay? So we have to make sure we have enough pairs to take away all the groups. So what I've done here is I've created 3 groups of 4 0 pairs, okay? So if I were to take away all the negative tiles, so I've circled all the negative tiles in step 2, right? And I take them all away, what I am left with is my answer, which is here, okay? And in this example, we're using yellow tiles to represent positive and red tiles to represent negative. So I've taken all of these groups away, and all I'm left with is these 12 positive tiles. So what we have is negative 3 times negative 4 gives me a positive 12, because the idea is that we must take away negative 4 here, okay? 3 times. We have to do that 3 times. So we have to take away negative 4 3 times, because it's negative 3 times negative 4. Okay, so we're going to end up with a positive answer. So really, when we are doing multiplication of two factors that are negative, we have, when the two factors are negative, we're actually going to get a positive number. Okay, so if we have a negative times a negative, we get a positive number. And this is always going to be the case. If we have two negative factors, it's going to give us a positive answer, okay? And so really what you then have to really, when we're doing this multiplication and division, all you really have to think about, okay, what are my signs? What's my answer going to be? And then what is the two factors multiplied together? So for example, if I have negative 2 times positive 7, okay, my first question to myself would be, okay, I know that 2 times 7 gives me 14. So I'm going to put 14 here. And then I'm going to look, okay, I have a negative and a positive, okay? So a negative times a positive gives me a negative, so my answer is negative 14. And it's as simple as that. Another example, if I were to do positive 2 times positive 12, okay, now that one is pretty straightforward. We've been doing 2 times 12 forever, and so I know that is a positive 24, okay. I'm going to give you another one, positive 4 times negative 5, okay, well, 4 times 5 is 20. If I look at my symbols, a positive and a negative, so that gives me a negative. And then as just one more example, if I had negative 3 times negative 6, okay, 3 times 6 is 18, and a negative times a negative gives me a positive. And really, that's all you have to think about when doing these types of questions. So, for division, really what you have to know first is the vocabulary, okay? And you have seen this vocabulary before, I am sure, but we're going to do a little bit of just vocabulary piece for that as well. So I'm going to give you an example. 6 divided by 2 equals 3, okay? So in this question, the 6 is the dividend, okay? That's usually the whole group which is being divided, okay? Or the number that's being divided, okay? And then a divisor, which is the 2. So this one was the 6, this is the 2. The divisor is the number the group is divided by. And then the last one, okay, is the quotient, so the 3. Now, really easily, that's the answer. But more technically, okay, when we say the number the group is being divided by, it's either, the answer is either the number of groups or the number of objects per group, okay? So the quotient is either the number of groups or the number of objects per group. But it really, realistically, is the answer. And that's the term we're going to use when we're talking about the quotients for multiplication, or division, sorry. Now, again, I would really never make you do a whole bunch of work to draw these division questions. But as we know, multiplication and division are related. So if the rules for multiplication, if we take those rules and we think about them when we're doing division, the rules are exactly the same, okay? So Again, when we're dividing a total number of objects into equal groups, we have a dividend of 18 divided by a divisor of 3. That's going to give us 6, okay? Because we have 6 groups per, or 6 objects per group. If we add some positive symbols in there, positive 12 divided by positive 4, we get positive 3. Now, again, so if both the dividend and the divisor are positive, nothing changes. The quotient will be positive. But if it's divided, if we have a dividend with one symbol and a divisor with the opposite symbol, so in this case our dividend is negative and our divisor is positive, we're going to get a negative number. Okay, so we're dividing them into groups of -3. And it could be, I could do positive 15 divided by -5, and I still have a positive and a negative, and I get -3 as my answer because I put it into negative groups. And this is why I would never ask you to draw this, because it's really, really confusing sometimes. Okay, so we just really have to look at the rules again. If the dividend is positive, or negative, as long and the divisor is negative, or even if both the dividend and divisor are negative, it is really difficult to model. But if you think that division is the opposite of multiplication, the same rules for multiplication apply for division. So what I mean by that is that we can then use these rules. And I've kind of put them into a little bit of a graphic to make it a little bit easier. So if we're looking at this, these are the rules that we talked about for multiplication, okay? So positive times, here, just let me get a highlighter here. So a positive times a positive in this first row equals a positive. And we have the same thing for a division question. So we're going to have a positive divided by a positive gives us a positive. Now, in these next two situations, no matter what the order, okay, whether the factors go positive, negative, or negative, positive, or the dividend and divisor go positive, negative, negative, positive, because we have opposing symbols, our answer is going to be negative. Okay, different symbols, our answer is going to be negative. And then in this last one, even though we have two negative factors and a negative dividend and a negative divisor, our answers, or our product and our quotient, are going to be positive. And the really easy way to remember this is that if the symbols are the same, the answer is positive. So now you're going to do a little bit of practice with this. And if you have any questions, please make sure that you ask.